Welcome back. In our lesson so far, we have been running applications, but we have been ignoring a giant real-world problem. What happened to your data when a container crashes? Or when you roll out a new deployment? The answer by default is that it's gone. A container file system is ephemeral. When the container stops, its data disappeared with it. This is the complete deal breaker for 90% of real applications. You can't run a database, a blog, or any application with user-uploaded contents if the data is just temporary. Now, Kubernetes does have a basic concept called a volume, which is great for sharing temporary files between two containers within the same pod. But it's still tied to the pod's lifecycle. When the pod dies, the empty dir is gone. We need true persistence. We need a way to manage a storage that lives completely independently of our pods, so our data can survive crashes, restart, and redeployments. In this lesson, we are going to master Kubernetes storage architecture. This system is built on few core, critical objects you absolutely must understand. First, there is a persistent volume, or PV. Think of this as a supply of storage. It's a real piece of storage, like NFS share, a cloud disk, or just a directory on the node. That's administrator provision and made available to the cluster. Second, there is a persistent volume claim, or PVC. This is request for storage. This is what you, a developer or user, create. You simply say, I need 5 GB of storage that can be written to. The magic of Kubernetes is how it bonds your request, the PVC, to the available supply, the PV. In this lesson, we will master the two ways this happens. First, we will learn static provisioning. This is the manual way, where an administrator pre-creates a list of persistent volumes. We will create a PV, then we will create a PVC that's claim it. We will learn all the key options, like capacity access mode, and the critical reclaim policy, which tells Kubernetes what to do with the data when you are done. Second, we will learn the modern preferred method, dynamic provisioning. Instead of admin making PVs, they just define as a storage class, like fast SSD or slow HDD. Then we as users simply create PVC and mention the class, and Kubernetes automatically create a brand new PV just for us on demand. Finally, we will learn the last step, how to take that PVC and mount it directly to our pod, giving our application a permanent, safe place to store its data. This is one of the most important concepts for running a real stateful applications in production. Let's get started.